Hello and welcome to Elektor Lab Talk number 16, Making Things with Modules. I'm Brian Tristan Williams coming to you live from Johannesburg, South Africa, where it's 5 p.m. on this Thursday, March 21st. Joining us is the sharp-minded Jens Nickel, our chief editor, and he's joining us from Aachen in Germany, home of Elektor Labs, where it's 4 p.m. Our senior engineer, Powerhouse Saad Imtiaz, was meant to be with us, but he's having some power grid issues over in Islamabad, Pakistan, where it's just after 8 p.m. now. But he says he might be able to join us shortly once he's resolved these issues. Already in the chat, I'm seeing people from the Netherlands, USA, France, Belgium, so it's a global talk show. And we're thrilled to have you here, so stay in your seat and let's explore together how these tiny blocks are building the future of electronics in Lab Talk episode number 16. Jens, we're hoping Saad can find a way to join us, but for now, how are you doing in Aachen?
I am doing fine, Brian. Thank you. Lab Talk is always a little bit improvised, and that's how it goes. And the show lives from that spontaneous things. And today it will be a little bit more improvised, but okay. I think we try to fill the gap, and let's come to interesting discussions.
Yeah, that's awesome. And let's talk about our giveaway. As you know, as we've put in the invitation page, we are today giving out, let me bring the, excuse me while I bring the slides up. Talk about improvised. Okay, I'm having trouble bringing that slide up, but today we're giving out 3 Arduino Uno R4 experimenter kits. So it comes with the Arduino Uno R4. It comes with a great book called Mastering the Arduino Uno R4, but that's not all. It's an entire experimenter kit with all kinds of modules and sensors. And if you take a look at, I've got a whole desk full of modules and sensors to go through today. And this kit comes with, I mean, everything from temperature sensors to stepper motor drivers, relay modules, sound modules, and a book full of experiments and projects. So that should be fun to do. And then, there we go. The slideshow is working. Yes, there's the book, and there are the projects and products you can look at. Now I have most of that on the desktop in front of me, as I said. So yeah, that's my mess at the moment. If you have any questions about any of that, just let me know. Jens, you've been doing some prototyping as well with modules. Could you tell us about that?
Yes, of course. And I think we can come more extensively later to that. First, in general, about modules or modular electronics. It's a thing which gives electronic engineers sometimes mixed feelings, because on the one hand, we are all we all like these modules because we can come faster to prototypes. And before the show, I quickly brainstormed with myself what happened, for example, in the last 20 years, because you may know I started 20 years ago as an editor for this electronics magazine. And I remember there were also modules, of course. I remember in our electronics lab, they used a lot of these FT232 boards. They were available as chips, but there were also boards for it. And I remember, for example, from Code Mercenaries from Germany, there were I/O boards, and I remember there were Ethernet boards where you can quickly connect your project to the Ethernet. So there were, of course, a lot of modules, but I think in the last years, the zoo of modules really explode. And I wonder why this happened. And I think the reason is, on the one hand, we have this maker movement where more people start to work with electronics. And yeah, there are a lot of people coming from the software side. I'm actually also coming more from the software and programming side. And yeah, I don't want to spend time or a lot of time on thinking about the correct dimensioning of resistors and capacitors. I want to quickly come to a working project. And then, yeah, of course, I take, for example, I take a step down module or something like that. And I think that makerish movement really also accelerated everything on the side of the real engineers, of the real developers in the companies, because they also want to come quicker than before to a working prototype. It's not so common anymore that you have to dive in a data sheet of 500 pages before you start with an evaluation board. You just want to quickly unbox it, and then you want to make your first examples, and maybe you connect something to this, and you want to make a prototype with it. And then you can evaluate if this is the right board for you. And I think that really has accelerated a little bit the requirement for fast prototyping that is heavier than ever before. And yeah, okay, all companies, they had to react. And yeah, you can see that even the more conservative companies, they also have modules, even analog modules, where you can quickly come to your own project, and you don't have to think about each component on these boards. Yeah, and on the other hand, I think it's also the market situation in Asia. It's easier than ever to produce quite cheaply, quite cheap electronics, and you can ship it from East Asia to Europe, and you can get modules really for €2, €1. If you want to make this PCB yourself, you need components for €5. So that makes really no sense anymore. So yeah, I think those things that really let the market of modules explode. And yeah, I think we can come later to the question that I would also ask our audience: what is your opinion about module electronics? Because as an editor-in-chief, I got, of course, feedback from both sides. There are really readers who are doing everything with modules. They even use evaluation boards, or they even use development boards in their projects, and they just connect modules to it with some wires, and then they also quickly come to software, because there's a lot of libraries, and yeah, you can come very quickly to a project, and then you test it, and you have a working electronics device. And yeah, well, on the other hand, there are of course people who say, okay, that's not real electronics anymore, because these people do not understand what's really playing on the component level. And yeah, I can understand both sides a little bit, but I think we don't have to decide in the electronic scene, and we don't have to decide for the magazine what we want to prefer. I think both sides have their rights, and yeah, we want to report on both things in the future in our magazine as well, the more modular electronics. And of course, also, if a reader offers me a real nice circuit on component level, there he has, of course, a lot of knowledge, and he has a lot of, how can I say, grip to all the details, then that is, of course, appreciated. But I think both sides have their rights.
Yeah, I think I share similar sentiments to you. And while we wait for the audience to tell us what do you think of modular electronics, You've given me some memories now. You were speaking about early prototyping, and this, for example, is an early board I had designed in about 1999, 2000. And it started off with Intel 8051 variant here. And back in those days, it was programmed all in assembly, native assembly. And I had to put a header here to plug into my PC's parallel port. And on the PC end, I had to write code to bit bang this chip in order to program it after assembling the code myself. And then if I wanted to add serial output, the normal DB9 serial connector, well, then it wasn't FTDI those days. It was a MAX232 chip there, which would convert the levels from plus and minus about 9 volts to the TTL levels. And then at a later stage, I wanted 2 of these boards to talk to each other wirelessly. So that's where this Bluetooth module came in. And that's a surface mount device. So I had to add it to a bit of Vero board with some wire. And then the LED would light up to show that, yes, indeed, our 2 modules boards are communicating. Now that was a lot of work and taught me a lot of things, and it would be so much easier to do now. You can get an Arduino off the shelf with Bluetooth, and there's no FTDI or FT232 or any of those things to worry about, because it's got a USB connector that you can just connect right up and type C code from the Arduino IDE, which is great. Now, I took a break from working on this kind of stuff in the early 2000s, and I went on to a different job, event management of all things, but I missed the electronics, so I came back to it, and there was Arduino with this simple USB, and you can just type in C, and that's not fair. I worked hard to learn all that stuff, but you know what, like you say, it's much easier and much quicker to do it this way, but it does help to have that underlying knowledge of how things work at the chip level, and what assembly is and what different voltage levels are and so on.
Yes, indeed.
So, get some comments from the audience. That's a nice one. I'm very happy working with modules, at least until the whole project is finished. Agreed. I would say prototype on an Arduino board. If I could find it here. There it is. Yeah, prototype on this. That's great. And you've got the pins sticking out and so on. But in your final project, you might not need a USB connector. You might not need this USB to TTL converter using up power unnecessarily. So then, yeah, prototyping on these is great, but eventually you can move to your own printed circuit board. So I agree with you, Mihai.
Yeah, I find it interesting what, for example, Ari is saying wired modules are great for prototyping and for real production, not usable. But however, he says SMD modules are great to avoid lots of RF testing. Yeah, that brings us to the point that, of course, there are very different modules. So module is not module. It begins with simple breakout boards, and I think everybody will say, okay, that using breakout boards is electronics because it's just passive wiring, and you avoid really difficult soldering. But okay, put some resistors and capacitors on that breakout board and you will have a module. And yeah, RF is also a good keyword because that is a really sophisticated task. And that's why we all are very happy with these modules, for example, from Espressif, where you really have that RF circuitry right in the module. And it is interesting that, for example, in our last guest edition, we made with Espressif, they have an article how to just use the bare, how can I say, ESP32 SOC on your own PCB, and you make all that RF accompanying circuitry around yourself. And yeah, it's a long article, and if I read it, I think it's very, very sophisticated. So I would always use minimum of home module, for example, where you just have to connect your own USB circuitry. maybe I would even use an ESP32 board. We can come later to this because in my latest pet project, I'm using a very small ESP32 controller. Yeah, as I said, module is not module. You have at least these breakout boards, and of course you have really sophisticated modules, maybe even with a microcontroller on it, and that also has its rights. For example, if you have a complicated sensor circuitry, I have actually one module on my desk which does a great job. So that is actually think it's the gravity zoo. So it's a gravity module. Gravity is that kind of connector where you have sometimes 3 pins, sometimes 4, 5. I think it goes up to 6. And they have very sophisticated sensor modules in their range of products. Maybe we can later have a look on their website. And yeah, it's basically a sound level meter. You know that measuring sound level is not so easy. You have to sample quite fast, and then you have to make an average. And you have to also apply some weighing curves to it. So it really gives at the end you a number which reflects the dB units really for the human level of sound. And yeah, I think that's a quite good module because you have all that circuitry, and there's a lot of.
Sorry, Jens, what is the name of the module that you've got there? I want to bring it up on screen.
That is the sound level meter from Gravity. And yeah, you have an interface which simply gives you a voltage from, I think, 0 to 3 volts, which linearly reflects your sound level. And that's, of course, a great advantage. It's not the most cheapest one. It's, I think, between 40 and 50 euros. But yeah, you can really build a level meter with ease. So yeah, I connected it to an ESP32 board, and yeah, then I want to have a level meter, a wireless level meter, where I can place somewhere in my room or at the field, and I can get the values remotely. So that maybe will help me later to make an automatic measurement of loudspeakers or something. So for me, that was really helpful.
Yeah, was it important for you to be able to measure sound level meters, or was it just a curious project for you?
Yeah, as I said, my latest pet project that is has to do with loudspeakers, and yeah, we want to remote control loudspeakers wirelessly, and yeah, we had the idea that we also can measure the sound level at a certain point, and later we want to apply pink noise to every loudspeaker, so we can measure the sound level, and we can then configure the volume of each loudspeaker, that the level for each of the loudspeakers is the same at a certain point. So that's a kind of automatic measurement system.
Well, at least you didn't have to design the analog end of that. That's a point made by Frank, saying it's a sign of the times, these modules. When digital electronics started to take off, analog trained technicians said that digital electronics weren't real electronics. And I can sympathize with that as someone who was useless at analog. The first circuit I built from Elektor was a PAL to RGB converter that was fully analog, but it was a kit, so it worked, but I could never design something like that. All those resistor calculations and capacitances, and if you do anything wrong, you've got noise and interference. I did some RF, but it was difficult. Digital, the signal is on or it's off until you get into like the gigahertz computing ranges.
Brian, somebody's asking about the code word for the giveaway.
Yes, we'll get to the code word a bit later, but we want to introduce Saad, who has gotten over his teething problems with the power over in Islamabad. How are you doing, Saad?
Great, thank you. Yeah, it's the last 1 hour has been an hassle trying to get the UPS set up and everything. It's nice to be here.
Well, I'm in South Africa. We can't keep the power on for most fully for most of the day on any day, so I'm running with a UPS as well. I come prepared. You are a newbie to power cuts.
Not a newbie, but yeah, was not using a UPS before for my computer. Was using it for as a backup as for light and fans, but now today I was able to set it up on I would say an emergency time, but able to do it.
Cool. So what did you think of the discussion that you heard so far? What do you think of modular electronics? Do they insult your training as a senior engineer?
So. No, I don't think so. I think it for starting with prototyping or getting started with electronics, these are, I think, the bare bones to get started with it. And of course, you can first of all a proof of concept time. I think it's a really good to have these modules out there. Otherwise, you're going to be tinkering with a lot of PCB parts and not working project things, and then you will be pulling your hair out. It's like, why this is not working? It's better to get some reference designs from these modules. Most of them are open source, so you can also copy the design into your own project, and then it becomes much easier. So yeah, to sum it all up, I think it's very useful for starting in. But of course, if it's a commercial type thing or an industrial scale project, then of course you don't need module inside of it. It needs to be an all-in-one PCB solution. So yeah.
There is also another facet to that discussion. I remember I'm always on the embedded world, and I remember that all these semiconductor manufacturers, they always offer these very cheap evaluation boards. And yeah, we can say the name here, ST Microelectronics. They offered very, very cheap evaluation boards at that time. I think even €5. And yeah, I'm also reading from time to time music magazines, and there was an article about a guy who wanted to make his own drum synthesizer, and it was so successful that he wanted to make a big scale production. And yeah, he also used that ST modules to make his first prototypes. And later, he was not allowed from ST to use these evaluation boards in larger scales. They had some limitation on that, so he had to design his own PCBs. He wanted to use these eval boards, but he was not allowed to. I am not sure if these things are still the case, but you also have to have an eye on that, of course. For some of modules, there may be also restrictions.
Yes, and I think speaking of MIDI, I worked on a project with one of my friends. He wanted to make a piano out of a MIDI, so we started with the Arduino Duo board and some of the MIDI modules. And we made the prototype, and after that he was saying, hey, I want to upscale it, and then we designed our own PCB after it, because of course the size, you have to factor in the size, because if you're using modules, then it takes more size. So having it for final product as a complete PCB is a good solution for sure.
Yeah, and what I was going to say is that sometimes it comes down to cost and time. Even though it's like in your mind, it's a horrible idea to have like something like this in a production run environment, but sometimes it's a small run. Maybe it's 20 boards that they need in some sort of automation, and then you wouldn't be surprised to find an Arduino lurking inside the enclosure, because it's just going to cost him too much time and engineer time, and therefore money, to go ahead and do a fully manufactured product.
Yeah, and of course there are modules which are dedicated also for larger scales. For example, Raspberry Pi compute modules or something like that. I think no one would make an own PCB. I think that makes no sense, because especially for that kind of applications, they made these very compact modules.
Yeah. Ari is speaking to my point that I said when you go up to gigahertz speeds, yes, try to go to gigabits per second digital. That becomes very analog. Yes, and out of my pay grade. I'll use a module for that. And speaking of analog, from CJ, maybe a laptop someday where we discuss all the different power-related challenges we face in all these different countries. It's a pretty interesting topic, yes, and yes, a lot of our readers find it pretty interesting. Whenever we publish something on our website, we get a lot of hits on that topic of power. But that's 50 hertz or 60 hertz, so yeah, we're not going to run into too many problems with stray capacitances and things. So Sat, what have you got in your bag of tricks for us today?
Well, Jens and I have been working on an app build project, which basically uses these 3 modules and become entire PCB. I don't have the all soldered PCB with me, but I have the PCB design with me right now. And as you can see in the middle, there's a space for the OLED display. Here you have the ADS 1015 space. I don't think it's blurring out. And then we have INA 169. So basically, you're able to measure current and voltage, and also having 12-bit precision with the ADC. And also, a lot of these connectors, or not connectors, modules out there would have various type of connectors, which sometimes become incompatible with the design. So we incorporated these XT60 PW connectors, which you probably see more times with the LiPo battery. So it becomes a very convenient solution for it. In testing, it's been working pretty much well, and we're also writing an article about it. So people interested to know about this will, get to know more of this in detail. And possibly missed out on the most important thing. It has 3 types of connections. So it has a groove connector for communication with any type of groove modules. Then we have a quick connector, and also we have a 2.54 pitch header for GST PH type of connectors for custom solutions if someone is building. Overall, it's in testing, it's been it's been working fine, but overall but I think we faced some issues with libraries, right, Jens?
Yeah.
And
some of them. That is of course another thing, another discussion. I first wanted to say about this M-Volt PCB, we made it modular by intention, because first we discussed that we maybe will use a controller right on the board. And then later we decided to make it modular, so it has on one side an I2C interface. So we said then you can connect it to the controller you want. Just take I2C, and as I think, especially these growth connectors are very convenient. We said, okay, a growth connector should be on one side, but okay, it has a certain pitch, so you can also solder another 2 millimeter connector. And growth is one of the examples where they have a lot of modules. I think you have to decide yourself, do I want to buy such a growth module, or do I maybe want to integrate the function on my PCB? I think for some of the modules, even me, I would not buy a growth module, for example, for a button or LED or something like that. I maybe would not buy a growth module. Maybe I would just take 2 wires and solder it directly to my target PCB or something like that. But for other growth modules, for example, I'm using in my project a mini motor driver PCB, and it has a lot of circuitry on that board. And I think the price is 6 or 7 euros. So for that price, we couldn't make an own motor driver PCB. But with my friend who is doing that loudspeaker project, yeah, we also had discussions. He was more on the side that we make a PCB where everything is on one board, and I was more on the modular side because, yeah, I think for prototyping and for the first tests you make in the field, it's maybe better if you have a modular system, because then you can replace one module by another. If you, for example, see, okay, the precision of the ADC is not good enough to have a good feedback about loudspeaker level, then you can upgrade easily to another more precise ADC. And if you already have everything on one board, you have to make another version of the board. So that's not so handy, I think, especially in the first stages. But that is always a matter of taste, and you have to decide yourself. And I think it depends also on your knowledge. Yeah, for myself, I'm especially for analog things still more at the beginner side, and yeah, that is why I really appreciate these modules. For example, as said, power regulation. That is just one example. Motor driver, all these things. Yeah, and coming to the libraries, especially for beginners. Yeah, I also started with these modules. I wired everything, and then I wanted to try it out. And the first thing you do, for example, if you have a growth module, you go on that page, Seed Electronics made for that special module. And then they recommend, if you are on the Arduino side, for example, they recommend Arduino libraries. And yeah, Saad and me, we made the experience that you really have to try out more than one library. That depends, for example, that a library is just usable for microchip-based Arduinos, and it's not usable for ASP32 controller boards. And there are also, of course, differences between the variants of ESP32. For example, I made the experience a library did not work for me, and then I more configured the board, the module of ESP32 I used more precisely in the Arduino configurator, and then it worked. And what you also should do is really update your board files. So, for example, if you integrated the ESP32 board files 1 or 2 years ago, a library could not work. And then update your board files, and that would be one tip. Yeah, but yeah, for some of the things, for example, I think Saad, for the external ADC, we really had to try out 2 or 3 libraries until we found one which really worked successfully without hiccups. And that can be for beginners a little bit tricky. And yeah, I also had the case that a documentation was outdated for a library. So obviously the developer, he changed his configuration or his defines, his constants, and he used in his own examples outdated version of his constants. And yeah, that is, of course, if you are a beginner, it's tricky. Then it's just not working. In one case, I had to go really in the functions of the libraries and comment some things out that it worked. So yeah, it's the, how can I say, the promise of these modules and the libraries is that even beginners, they just plug and play and they have a working thing, but sometimes it's not so easy.
Yeah, and also when you're dealing with the I2C protocol, sometimes if you buy a cheap, module from AliExpress or somewhere, normally they use some kind of ICs which are not giving out the same exact address of that I2C protocol which is mentioned in the data sheet.
Yeah,
So
they
that
sometimes
I
change
faced
that.
it.
Yes.
Yeah, so you have to run a I2C scan on
Yes.
while connected your board, and you have to get that right address in order to make that audio work for you. So that's also really important.
Or in the documentation, it's stated that they bridged some solder points, and at the PCB you actually have in your hands, there's no bridge, and yeah, all these hiccups.
Yes.
So you have to really first investigate, do I really have the same PCB? Do I really have the latest documentation of this? And yeah, that can be tricky.
Okay, can I just jump in now to say that we've past halftime, and I just want to remind viewers of our laptop giveaway. It's the one of 3 Uno R4 Minima bundles. So it comes with what you see there in the picture, the book, Mastering the Arduino Uno R4 from Elektor Publishing, and the R4 Minima, but not only that, as I said earlier, a whole bunch of these modules and lots of projects for you to try it with them. Now, people are asking for the code word. Yes, that's the Easter egg. We have Easter coming up, so we've got to make you work for it a bit. Here's your code word. It's modular. Some of you are saying that the link didn't work earlier, but if you have fat fingers like me, well, there's a QR code. You can scan that if you like. And yeah, visit our website, enter the code word, enter your details, and good luck, because we've got 3 of those to give away to you. Now, you were talking about the Grove connectors, and a point here made by Evelyn, sorry if I'm pronouncing that incorrectly. Modules with DuPont connectors and cables are okay, but I hate the ecosystems where everything has to be connected with proprietary connectors. Are the Grove connectors proprietary?
Half, let us say. And that is, you have to investigate this. A lot of people say it's a proprietary connector. That is why, for example, my friend Marco, he never liked it. He said, okay, you always have, then you have to stick to the Grove connectors. But yeah, Saad found out it's actually in, I think, GST XH connector or something like that. I think in KiCad it's PH. Yeah, but Seed, they made a small modification. So I think the PH connectors, they are also fitting, but the actual Grove connectors, they have a kind of how do they call?
Which one?
What is the change from the actual Grove connector to that PH?
Oh yeah. Yes, the main change is that they have this small clip on the top, so so it can have a strong connection. Yeah, I would not recommend to have it, because sometimes it's a little bit hard. You have to be really squeeze the connector in order to get it out. But normal PH connector is fine. In the past, when I was making these projects, even in the aviation sector, we use a 2.54 millimeter pitch connectors. I think it is an XH connector, GST XH connector.
Yeah.
And then the main benefit of having that is that you can use a header, and you can also use a connector, rather than they're having a 2 millimeter connection with a PH or a Groove module. And it becomes a very interesting topic.
Yeah, a disadvantage of the Grove system is that they use a 2 millimeter pitch, but not only Grove, also a lot of other ecosystems, they use a 2 millimeter pitch connector, and that you cannot easily solder on these usual breadboards or Vero boards or prototyping boards, because they always have the 1/10 inch, so 2.54 millimeters. So that is a disadvantage. There are, of course, prototyping PCBs with 2 millimeter pitch, but they are very exotic and they are very expensive. So then you always have to buy a bridging PCB or a prototyping PCB, also from Grove, for example. But okay, it's of course not the holy grail to use modules. They always have disadvantages, and yeah, I think for first prototyping and testing, also under wider circumstances, I think they have its benefit, and then later you can of course decide to make your own PCB.
Yes, and also you have to stick to one type of, I would say, connectivity thing or interface. So if you're making a project and you want to stick to the Groove, then you're gonna have to stick with the Groove. Otherwise, you're gonna have to, link in other type of modules. And for that reason, we introduced, Quick and Groove connector, and also those 3 types of connectors, so it can be used in different types of projects or different types of, environments.
But there are bridging PCBs. I think, for example, from Quick to Grove, there are bridging PCBs, but they are not cheap.
Exactly.
If we've got a lull here, thanks to Asma for sending us this question, which came in on Instagram. Hamzarif07. I come across multiple Chinese modules with very poor to no documentation. How can I get information about it? One module's pins were labeled MOSI and clock, even though that was I2C module. That is I would expect that to be serial peripheral interface, and you say it was I2C module. It depends on the module, but yeah, you can't always guarantee the quality of what you're getting, especially when you're paying bargain basement prices, right, guys?
Yeah, and some of the modules out there, I have both interfaces, so SPI and also I2C. It depends on the chip which is using which they are using it. But if you fall into some problem is you cannot get it to work, you're gonna need to have an oscilloscope in order to know what type of interface it is, or if it's actually outputting a serial output or not. So yeah, that is also very important. And also there are also some ICs out there which also do serial output as well, with SPI and I2C, and it becomes a little bit tricky. Which one do you have it on your desk, and which one is actually in the document sheet about? So yeah, you're gonna have to do some testing if you fall across some module like this.
Yeah, I would also say maybe it is I2C and they just did not change the label.
Screen. Yeah.
Yeah. You guys always reminding me of stuff, because I spoke about this old board and having to bit bang the programming, and there's a header right there, but that was a serial peripheral interface to program the flash memory on here. But of course I had no modules to do the SPI for me, so again it was bit banging on the PC's parallel port, and I didn't have an oscilloscope, but luckily it's a digital signal, so I was able to do like logic analysis using the parallel port, even if it meant grabbing the data very quickly to available memory on the PC in assembly, dumping that out to a file, and then analyzing it, say in QBasic. The things you do when you don't have the right tools, or you can't afford the right tools. Again, rock bottom prices, but the advantage is you learn a lot that way. And I was just bringing this up because we were talking about all the modular manufacturers. There are boards for boards and modules for modules on all these sites. There's Micro E.
Especially, especially microelectronic. It's really impressive. you have to, if you are on a fair, you have to go there. There sometimes have big desks with several hundreds of these clickboards. I think it's should be the biggest ecosystem. I'm not sure, but they really have an impressive amount. I think they even have 500 sensor boards or something like that for all
Wow.
different gases and what the heck. It's really a very big ecosystem.
Well, I see this is the page for clickboards, and we're on page 1 of 139, so that does sound like quite a big ecosystem.
Yes.
You could
Yes,
lose some
they have,
hours there to visit
I think
them.
as about 1,600 boards.
Wow. Okay. Well, I can see how you could lose a couple of hours at their stand at a show. Then, of course, you've got official Arduino shields and carriers. I don't think I have any official Arduino shields. Pretty much hook them up to modules. And these shields, I don't know, in my experience, they used to be expensive. I don't know if they still are. Do you guys use Arduino shields?
Well, I don't have anyone except I think the Protenta breakout board because the Protenta is so small and has that high input-output pins where you can stack it out and you can have a bigger breakout board in order to use it. But in the start, I think for prototyping, an initial boom of these electronics and makery projects, these were the boards out there which people were using, especially their maker series was used. People were making weather stations and GPS modules and everything was there. But they are useful for sure. But now there's so much, I would say, options now that one does not have to stick with one maker or one manufacturer. There are so many options, and they can decide which works best for them.
Yeah, and
Yes,
it does
yes,
seem like there still are.
I also worked maybe 10 years ago or something like that, a lot with Arduino Uno, and I even designed my own shield, not the PCB, but I determined what to put on that shield. I think it was called the beginner's Arduino beginner shield or something like that. There is an Elektor article about it, and it had a display and it had a potentiometer on it, and something
Not that
like
one.
that.
We'll have to find it in the Elektor article. Maybe we can look that up. But yeah, they do seem to be still quite expensive. I mean, €12 almost for a proto shield. In the beginning, I think some shields were important, like maybe Ethernet, and then later Wi-Fi, but even those are expensive. Now we don't need that. We've got so many variants with Wi-Fi built in. Let's take a look at some of these other manufacturers. How about DF Robot? There's an interesting one right there.
These are these gravity boards, and it's they are high priced, but they are really sophisticated. They even have industrial grade sensors, which you can really use in very wild environments. And
so your gravity board from earlier would have come from them. And we were just speaking about shields. This is much cheaper than an official Arduino shield, and look at everything that comes on it for $9. I've always wanted to experiment with something that can play a little bit of sound based on, I don't know, a Halloween prank or something like that. More sensors from gravity. Human presence detection. Yeah, there's a lot to choose from, and that makes this question relevant. It's from Daniel. I am new to modular electronics. Which board manufacturer would you recommend to get started with this?
It's a very interesting question.
Yes, depends a little bit what you want to do. If you want to really learn and make simple demo projects just to learn something, then maybe a good start would be to buy such an experimental kit, for example. And there you can really get in touch with different sensors, for example. And yeah, you will learn that there are sensors which are interfaced by I2C. You will learn that there are sensors which gives a voltage. And you will learn how to connect an LED and what is the purpose of a relay or all these things. And yeah, if you are on that really beginner stage, I would maybe buy such a kit. And yeah, you can Google a little bit, or you go to the Elektor store. We also have a lot of kits. I think we also have Grove kits, and we have Arduino kits, and yeah.
Oh yeah, we've got Grove, we've got Seed Studio, we've got you name it. But
I would recommend
community here, and in answer, yeah.
Yeah, I would recommend that if someone's getting started, then it should be possibly Groove kit, because they have a really good working libraries. I never had problem with working with Groove libraries. So yeah, first of all, you need to know how it works, and then you can start moving on forward with different type of interfaces and environments and everything. So it's start with the basics, and then after that, try new different things, think about a project and try to make it. And that's how you learn electronics and embedded systems.
Yeah. And a tip for Daniel asking which ones to use. Well, Mihai has used modules from ST and DF Robot, which we were just talking about. Let's just go back to looking at some of these manufacturers. Pimeroni, something I like about Pimeroni. You get a lot of different, maybe it's because they're so colorful, but I did get a Pimeroni LED hat for Raspberry Pi, and it's this one here. It's easy to program. You just plug it in straight away, and you can make cool little light shows with it. You guys use much of Pimeroni?
I think I was able to get some hands-on with their Enviro Raspberry Pi sensor. So they have a bunch of sensor which has air quality, temperature, humidity on the same thing, and then also you have a display. But yeah, it's I would only recommend it if you want a really a very concise type of setup, where you just want to have a Raspberry Pi, and on top of that you can have this type of hat interface with Pimeroni. But yeah, you're not going to be looking at the LED all the time. But what I would prefer is an IoT solution, and getting your own modules and plugging it to the internet, maybe using Arduino Cloud or ThingSpeak, and that becomes really handy.
Yeah. Well, maybe I'm just that deer in the headlights with colorful lights. I come from the 80s where no LED, no robots. This is another cool kit of theirs. It's a 16-key keypad that you can use as an HID device on your PC, but you plug in a Raspberry Pi Pico, which does the thinking work. This is just a keypad, and yeah, you've got your own little drum machine or macro keyboard or whatever you would want from there, which of course is available there. More from Pimeroni, breakout boards and electronics. And of course, Key Studio. Any experience with them?
No.
I do have some moisture sensors, but I don't think they're necessarily from Key Studio. And of course, there's WaveShare. They do a lot of cool stuff. In fact, this little robot I got also, let me just full screen myself. Or try to. Yeah, there we go. Cool little robot. At the moment, it doesn't have any brains because it's also Raspberry Pi Pico based, and I've removed the Pico because I needed to use it for something else. But again, all modular. For example, here's a ultrasonic sensor on the front. It's a module. Now, it's not only brainless, it can't see either. So at least I've worked with that a little bit. What you guys worked with WaveShare at all?
I think I've used their soil sensors for my plants upstairs. They work fine, and I think that was the only sensor I was getting to hands on here. But yeah, they make a bunch of other sensors as well. Their MP3, SD cards reader, and then their RTC is what I've used in the past, and also an OLED display. But now you could get the OLED display pretty much cheap everywhere. So not specifically, like I said before, now there are so many options. You don't have to specifically choose one of the manufacturer. You can get different boards from everywhere, and then make something good with it.
Cool. And then I should mention that I've got a local supplier. This is not an ad by any means, but to get stuff shipped from overseas always takes much longer. So I go here for breakout boards and modules. And again, this look at the categories here. It just goes on and on and on. It's so simple to get stuff nowadays. We used to have to wire it up all ourselves. And then moving on, I just want to mention that we had Pi Day recently, and it was celebrated by some, especially the Raspberry Pi Foundation. Seed Studio, speaking of them, they did some Raspberry Pi project sharing, so maybe check that out. You can probably see the URL at the top there. And not only a web page, oh, that looks pretty cool. They devoted a video, a live stream actually, 46 minutes here on YouTube, just for Pi Day. Explore Raspberry Pi projects at our Pi Day celebration. And Jeff Geerling, he overclocked his Pi to 3.14 gigahertz for Pi Day. So that was also an interesting watch. I'm getting a Raspberry Pi 5 water cooler soon. I'm not sure if it's something that's needed, but if you're going to be overclocking, that would be something to look into. And of course, not only Raspberry Pi Day, there was also Arduino Day this month, and they're having 3 Arduino days. There's one happening today. That does not mean change the channel, people. March 21st, March 22nd, and of course on Saturday, March 23rd. And there's a lot of interesting stuff going on there. In fact, later on today, once our show is over, at 6:41 p.m. CET, they've got Cloud Connected Creativity hands-on demo with Arduino R4 and SparkFront sensors. So sensors, modules, and maybe you have an R4, or maybe you'll win the R4 kit. So that might be worth looking at a bit later. Then they've got a day 2, which is tomorrow, and a day 3 on Saturday with introducing Arduino Community Day. I'm just dipping into this to show you that there have been some celebrations for that stuff. Well, did you guys have some Pi at least on March 14th? Nothing? No Pi? Okay, well, next year maybe I'll bake a Raspberry Pi. Jens, you were talking about a prototype that you put together for modules. I'm curious to see what that was. Do you want to go through that?
Yeah, we can take a brief look, because yeah, we are far in the time. Time really flies.
Okay.
Yeah, that's I think the second prototype we made for that loudspeaker electronics box. And yeah, you can see on the right side there's an Alps potentiometer that we control the volume of a small mini class D amplifier. And yeah, it's a stereo potentiometer, so we use one of the channels to control actually the volume of that amplifier, which is a mono amplifier, I have to say, because we use one power supply and one electronics at each of the loudspeakers. So that is the idea behind that system. And the other channel we use as a feedback about the level of the potentiometer. And yeah, in more to the left, there's one module the mini mod module, which controls the motor current. And what you see with these screw clamps, that is a cheap trick we used, because actually we had no growth connected PCB for the breakout board for that external ADC. So I discovered in the internet there were development boards where you could put on an ESP32 in the middle, and at the end you had for each of the pins a small screw clamp. And I just cut that in half, and then we could put the breakout board in, and we had the pins connected to screw clamps. So we had a first simple target board for that breakout PCB ADC breakout board. And yeah, more on the left there is the controller board. It is ESP32 based, and it's actually a Xio, which is also coming from Seed. And yeah, it's basically an ESP module and a USB connector on it. And this is connected to a target board where you have all kinds of growth connectors. So for us, that is a prototype where we really can live with. You can have some vibrations. It will not lose the connections. And we are still very, very flexible with it. So as said, with very low effort, we could change one ADC to another, or we could put even 2 motor potentiometers in that box. So for me, that really does the trick. And yeah, it's also not that expensive. All these modules are ranging from, let us say, €3 to €7 or €8. The most expensive part is the potentiometer, but yeah, we wanted to have some quality. And yeah, that is the first prototype, and we see what comes. Maybe we will have later a PCB which really integrates everything. But okay, it's a first prototype, and the latest idea was that we have a fallback if we don't have a stable Wi-Fi connection. Maybe we have an environment where there is a lot of traffic or what the heck, or a Wi-Fi controller breaks down or something like that. Then we have the option to also control that by infrared remote control. And you can see that module at the top right. That is a growth module with an IR receiver on it. And there I discovered a very, very powerful library, which really makes the life very easy. I think it's also documented officially on the Arduino website. I forgot the name. Infrared wireless or something like that. And that really makes the life very easy, because they have an example program you just upload to your controller, and then you use a remote control you want to use, and you just press a button, and they give you the exact code and the key code, the system of this IR key, and some other information. And that this you can then also use to make your own system with your own IR transmitter. You can just mimic that key. So that is a really powerful library, which really makes life easier. Brian, I discovered there are also some questions we did not answer so far.
Oh yeah, we've got some questions. We'll take a look at your board afterwards. Just switch to the other view. questions and comments. Mihai says that a lot of sensors from DF Robot use 2.54 millimeter pitch headers, so standard headers.
Yes.
So not proprietary.
Can be the case, but the most of the connectors I found, they have 2 millimeters pitch or even less, because everybody wants small modules and compact modules and small connectors. So I think if you really have a 2.54 pitch connector, that's really an exception.
Okay. Question on, speaking of connectors, Pogo pin connectors are being marketed a lot nowadays as a better option for firmware upload. Would you suggest using that? I'm thinking about giving them a shot. Well, first, from my end, I would say that if you are programming a whole bunch in series, like a production line, then you don't have time to be plugging, unplugging, plugging, unplugging. But it wouldn't make much difference for me with small scale experiments. What do you guys think?
Maybe Sat, have you some experience with Pogo connectors?
No, never. I never used Pogo.
Okay, I've seen them used on, for example, Adafruit videos, but again, it's because they got to sit there the whole day and quickly troubleshoot things. I mean, I've seen cell phones back in the days when you could take the battery out. They always had a little header there that you could push a Pogo pin to. Evelyn, no, this new Arduino Uno R4 is not the same as the Elektor Uno R4 back in 2017. We were just being cheeky with the naming conventions.
Yes, definitely no. That was
Take a look at
a nice joke from Clemens that time, from our colleague, to call it R4.
Yeah, Clemens is quite the joker, and I would watch your back if I were you, because April 1st is coming up. Do you want to tell me about this board now? The code word for the giveaway, Baltic Lab, is modular. Okay, back to your circuit, Jens. Can I switch to the PCB?
You can, yeah. Just some few words about that. That is actually then our solution for that ADC. You see that is a very simple PCB, and we can connect that ADC breakout board to it, and at the top you see some growth connectors. So I have I2C control, and I have some other growth connectors to as an analog input. And as you can see, there are at least 3 ADC breakout boards with this 12-bit ADC, which are pin compatible, which is good. So you can choose the one you like, and you can put it at that very simple target board. And yeah, most likely we will report on it in the Circuit Special of 2024. It's a very simple PCB, but I'm very proud of, because that's really my first fully designed KiCad PCB.
Yeah. Well, it's another thing that's gotten so much easier. I mean, Sad, you showed us a board earlier. You buy them in what, ones? Single
But
units?
I really like KiCad. It's really for beginners, and it's really a very powerful program.
Sorry, Brian, what was the question?
I was wondering if you're still there or if you were frozen. You make boards nowadays, and you can order them in like singles just for your prototype, and it costs next to nothing, and it's delivered very quickly, right?
Yes, exactly. I mean, I order it in 5s or 10s. Mostly for the initial prototypes, I order in 5. And then when it's pretty much done and I want to use it in multiple places, then in 10. But yeah, you can order your PCB and you're going to get it in 10 days now. It's been pretty fast experience with these manufacturers.
Yeah, that's very different from back in the day, this board that I told you about earlier. I had to order 100 of these to get this made. Now I still have about 92 of them unused, but I don't have the heart to throw them out. They're so pretty and shiny with a nice silk screen, but nowadays it's so much easier. Any other questions? No, I don't see any pressing questions right now. I will say, shall we wrap it up now, guys, considering we've gone 1 hour, 10 minutes in? Okay. A reminder, though, of our next lab talk. It's April 10th, 2024, and this time it will come live from the field at Embedded World Exhibition and Conference. So that's 11 a.m. Central European summertime. I guess it's summer. And 9 a.m. UTC. That's, yeah, you guys are going to change your clocks in Europe at the end of March, and then you'll be on the same time zone as I am. Elektor will also be there with the booth. So go and check out the Embedded World Exhibition Conference website. And besides that lab talk, just always visit us. There's a QR code, elektormagazine.com/elektor-lab-talk. And that's interesting. We say dash or hyphen, but I was listening to German radio yesterday and they still say minus. Those are minus signs. I'm
Yeah,
overheating here.
some people say minus. Yeah.
Yeah. We've just gone into autumn, and you guys are up in the northern hemisphere. You've just gone into spring, and I am still hot here. I've had to turn the air conditioner off again to accommodate you guys and not have noise in the background. But if I'm a bit shiny, that's why. Thanks everyone for joining us from all around the world, and very many interesting questions. I wish you luck with that giveaway. And Jens, nice PCB, by the way, and Saad as well. I want to make something now. It's been a couple years. Jens, have a safe trip back to Cologne.
Thank you, Brian.
And Saad, thanks again for joining us after your power issues in Islamabad in Pakistan, where, I'm sorry we kept you up until after 9, but then again, it is a public holiday here in South Africa and I'm working, so if I can handle it, you can handle it. Anyway, thanks once again to everyone for joining us. Go to our YouTube channel if you're not watching there already. Elektor.tv is the shortcut to getting there, and then like and subscribe. And you can also see news of an upcoming live web stream, which I'll be bringing to you next Wednesday with Great Scott, who's another influential electronic YouTuber. Thank you very much, everyone, and good night, good morning, good afternoon, wherever you are in the world and whatever your time is. Cheers.